Okay, IED, this is project 1.3.7, Design a Protective Case. We're focusing this time specifically on develop a solution. So we've defined the problem. We know exactly what kind of what we know at least what the problem is. We've generated concepts and we've done a decision matrix so we know what we're doing. Now we're going to actually start trying to develop that solution. So what we're going to be doing now is you're going to assign either the top or the bottom of the container to you and your partner. So you're not doing both at the same time. You're doing one side, your partner is doing the other side. So if you're doing the bottom, your partner is doing the top. You have to work together on this to make sure that your top and bottom will actually line up together with each other because they're separated by, or they're connected by a hinge, I should say. Okay, so it says individually develop a CAD model and multi-view drawing of your assigned component based on the new dimensions you have selected for the box. Use the same hinge design and snap fit clasp design used in the competitor's protective container. Work with your partner to ensure that the cylindrical hinge forms on each part that they align with each other. Ensure that you have a 0.5 millimeter gap between the parts at the hinge interface. This is to prevent things from sticking together if your 3D printer squishes too much of the plastic together. Depending on which plastic you use, sometimes plastic, whenever it cools, it shrinks down. So even if you thought that it was a certain distance, that this will shrink in and it won't end up being exactly that way. If you don't have a lot of experience with a 3D printer, assume that each one of these sections between here needs a 0.5 millimeter gap so that you're taking into account the plastic cooling and then shrinking back in. There are some plastics that don't necessarily shrink when they cool, like PETG, so if you're using that, you don't have to worry near as much about it, but a general safe assumption is to just go ahead and put in that 0.5 millimeter gap in between those two. Okay, let's see, the snap fit clasp on top aligns with the rectangular receiving hole on the bottom, so there's going to be a hole right here. Whenever it flips around, it needs to be able to clasp inside that hole. Um, let's see, and then the last one says important, emboss the name of your product or other identifying text on your components to distinguish them from other printed components. So there needs to be some way to identify that this case is yours and not just some other random case. So you're adding a unique element to it. So you're going to put some text on there to show that this is actually your product. So you're going to do a sketch and use the text command and then try to put that on there. While we're working on this in class, I'll help you guys with that as you need it. Let's see here. So it basically right here it talks about the 3D printer and how it actually works. That 0.5 millimeter gap is probably going to be useful for you guys. And then after you're done with that, check and make sure that your partner actually set up everything correctly. Y'all should be communicating with each other through the entire process. But it says, peer review your partner's multi-view drawing and offer effective feedback. Verify that your partner's component aligns properly with your component. There's a couple of things that you guys can do for that. One thing is that you can, in Onshape, import two parts together, have them send the part to you, and you send the part to them, and you'll try to put it together in an assembly and see if it actually fits together correctly. If it doesn't fit together correctly, you need to go back and you need to correct some of these things. You only have one shot on the 3D printer. You're not going to be able to make multiple designs. So whenever you're doing your proof of concept, you need to get it right the first time. Otherwise, it's not going to be a very good proof of concept. It's going to be a proof of we don't want to do it. Okay, so make sure that the interfacing male and female hinge forms a line and they're properly sized. And then make sure that the clasp aligns properly with the groove on the other component. So basically, you're just checking and making sure that it will actually snap in and it will actually fit, and that you're not making something that's a little bit cattywampus. Okay, so and then I think that's pretty much it for reviewing. And what I'll be needing for a deliverable for you on this is you're going to be making this 3D model. So a multi-view drawing of your 3D model will be perfect for this, for you to turn in for develop a solution because that's going to take all of your information should be on that multi-view drawing. You should be able to show me everything that you did there. I don't think you need to really turn in anything else for that. So for develop a solution, you're going to need to be turning in a multi-view drawing of your individual part. Okay, not necessarily the two parts put together, but just your individual part that you did. Okay, have a great day, and we'll talk later.